Alright, I thought I would do one more polar to rectangular just to make sure that we're solid. Or if you want to go ahead and pause it and find your answers and then check to see if you've got the same thing I do, then that would be a good idea. Okay, so we've got x equals, and we've got y equals. We need to find both, right? Well, x equals r cosine theta, and y equals r sine theta. It's really easy for me to remember those because you remember on the unit circle, you know that the first is the x and the second is the y. So x in cosine and y in sine have that relationship. So x equals r cosine and y equals r sine. Okay, so in a situation like this, I've got the radius and I've got the angle. X equals the radius 5 times the cosine of negative 2 pi over 3. So didn't I literally just do that angle? Am I just crazy? No, I'm not crazy. Negative 5 pi over 6. Oh, 2/3. Oh my gosh. Wow. I was about to put that here. It's not there. It's there. Okay. Okay. All right. Excuse my brain. All right. 2 pi over 3 is right here, so negative 2 pi over 3 would be right here, this coordinate point right here. So when I need the cosine, I know that the cosine of negative 2 pi over 3 is the negative 1/2. So 5 times negative 1/2, that is negative 5 halves. That is the x, and then the y is 5 times the sine of negative 2 pi over 3. So that would be 5 times negative square root of 3 over 2, which would be negative 5 root 3 over 2. And this makes sense. This coordinate point in the xy coordinate plane, negative 2.5 and then negative 2.5 times square root of 3, whatever that is in the third quadrant, and that makes sense for this one. If I go backwards 2/3 pi, it puts me right here, and then out a radius of 5. So it put me like right here. So, yeah, that makes sense. So go left 5 halves, and then go square root of 3 times that. So 1 point something times that down. Okay? Oh, no, you can see that. There you go. Okay, now we're going to go backwards. We're going to go from rectangular to polar. Now, rectangular to polar is a little bit interesting because remember, when we're in polar coordinates, there is more than one way to get to a coordinate point, whereas in rectangular there's only one. There's an x and a y, and you've got to have it, right? So this you got to be a little particular about your answer. In that you have the correct one, it can be in multiple options. What you don't want to do is accidentally give the wrong position. So first off, what we want to do is just write down this coordinate point, and let's remind ourselves of what quadrant we're in. This is an x and this is a y. This is a positive and this is a negative. So if I go positive and the negative, I should be in the fourth quadrant. So we're going to make sure that our theta and our radius is going to get us to the fourth quadrant. Okay? All right. So if I have an x and a y and I want the r, then I'm going to use this Pythagorean relationship. 3 square root of 2 over 2 squared plus, so I've got the x squared plus the y squared, negative 3 square root of 2 over 2 squared equals the radius squared. Or you could say radius equals the plus minus square root, but whatever. So I've got 3 squared, square root of 2 squared, 2 squared. I've got 9 times 2 divided by 4. Cool? Or 9 halves. Plus. This is the exact same thing, only it's negative, but a negative squared is positive, so it would be 9 halves again. Which means a half 9 plus another half 9 is 9. Or you could say this is 18 halves, and that is 9. Which means r could be either plus or minus 3. So we're going to keep that in mind, right? And then we're going to go with finding theta. Theta equals tan inverse of y, negative 3 root 2 over 2, divided by x, positive 3 root 2 divided by 2. Something divided by itself is 1, and so a negative something divided by itself is negative 1. So theta equals tan inverse of negative 1. Now this is going to be important where you remember how to deal with inverses, inverse trig functions. This is the same thing as me taking the tangent of both sides and thinking, because sometimes it's easier to think of it this way. Tangent of what angle is negative 1? So this is what we're trying to find. Tangent of what angle is negative 1? So we go in here, right? And we look at this and we say, okay, well, I know that tangent is the y over the x. 0 divided by 1 is 0. 1 half divided by the square root of 3 over 2 is 1 over root 3 or root 3 over 3, right? Square root of 2 divided by 2 divided by square root of 2 over 2 is 1. Okay, so when they're the same thing, the tangent, y divided by x, sine divided by cosine, I get 1, but I need negative 1, so I need to look over here. Because the x-coordinate is negative, whereas the y-coordinate is positive. So something divided by the negative of itself would give me negative 1. So I've got this as an option, but then I've also got this as an option. Not that one over there, because they're both negative. And two negatives would simplify down to a positive. So I've got that option and I've got this option. So what I'm going to do is I'm going to think about them both. Theta could be either 3 pi over 4 or 7 pi over 4, depending on the radius, right? Well, keep in mind, I need to end up in the fourth quarter. So the easier way to do this would be to say a positive radius and the angle that's in that quadrant, 7 pi over 4. So that would be the easiest way to do that, because 7 pi over 4 is the one that is in this quadrant. But I could also say I could go to 3 pi over 4, but then have a negative radius, right? So if I have a negative radius, it would pop me over to here. But then I also just know that there are other ways for me to get to that coordinate point, right? Because we're talking about 1, 2, 3. So we went here, we went 7 pi over 4 and out a radius of 3. But I could also go backwards, pi over 4, with a positive radius. Or I could go backwards to 3 pi over 4, which would be negative 5 pi over 4. So if I go negative 5 pi over 4 with a negative radius, that would pop me across the pole and put me there. So this is the most obvious. Positive radius, go exactly to that quadrant. This one gives you the other angle. That was your option, using tan inverse, but with a negative radius, and these two are the coterminals of those. But they're all correct. All right. We're going to do, we're all going to do. We're going to do 3 more coordinate points and then we'll be done, okay? With this. So, I've got an x and I've got a y, and I need an r and a theta. So, I know x squared plus y squared equals r squared. X squared plus y squared. Ugh. Squared it already. Equals r squared. A negative squared is positive. 7 squared is 49. Square root of 3 squared is 3. 2 squared is 4. And then you can think of it like this. There are 3 49 fourths, and then there is 1 49 fourths. That is, in fact, 4 49 fourths. You could say what 49 times 3 is, right? But I like to think of it as this is 3 49 fourths plus another 49 fourths. Those are the exact same, so it's just 4 49 fourths, which is 49. If you worked it out, 3 times 40 is 120 plus 27, so that's 147 fourths plus 49 fourths. 147 plus 100 or plus 49 would be 196 divided by 4, and 196 divided by 4. 4 goes into 19. Let's see. Yeah, 4 times 4 times 4 is 16. Subtract, and 36. 4 goes into 36 9 times. So there you go. 196 fourths is 49. But if you recognize these patterns, it makes it a little bit easier yourself. 3 of them plus 1 of them is just 4 of them. Okay, so that means r could be plus or minus 7. So now we need to find the theta. I know that theta equals tan inverse of y divided by x, so y divided by x. And that simplifies, if you remember when you divide one fraction by another, you can multiply by the reciprocal in the numerator and denominator. I'm going to go ahead and remind you of why. If you multiply by the reciprocal of the denominator, I'm going to go ahead and keep the negative on top. Then on top and bottom, we can do this because, remember, by multiplying by this divided by this, which is what I'm doing. Yeah, let me think of it that way. By multiplying by this fraction, I'm multiplying by 1, because something divided by itself is 1. But these two simplify out with each other, and then I'm just left with this, right? The 2 simplify, the 7 simplify, I'm left with a negative 1 on top. This is negative 1 over the square root of 3, or negative root 3 over 3. But I'm going to go ahead and leave it like this because that is a little bit more informative as far as the unit circle goes. Theta equals tan inverse of negative 1 over the square root of 3, or tangent of some angle is negative 1 over the square root of 3. True? So I'm going to remember what tangent involves. It's y over x. True? So if I go y over x, 0 over 1, 1 over the square root of 3, square root of 2 over 2, square root of 3 over 1, the 2's always simplify out. Then you can see that here we get 1 over the square root of 3. That is the type of problem that I'm dealing with. That's the kind of number I'm dealing with. 1 divided by the square root of 3, but I need to be negative. So again, I'm in these two quadrants. It's kind of boring. I wish I hadn't done that, but oh well. Okay. Okay. So 0, 1, negative square root of 3 over 2. 1 divided by the square root of 3? Not quite. 1 divided by negative square root of 3? Yes. Negative 1 divided by negative square root of 3? No, that's positive. And then negative 1 divided by the square root of 3. So these are my two angles, okay? 5 pi over 6 and 11 pi over 6, or 150 and 330 degrees. We'll go ahead and go with degrees this time. So I know theta could be 150 degrees or 330 degrees. But then I'm going to go back and think, where is that coordinate point? If I go negative x and positive y, that puts me in the second quadrant. So 150 is the one in the second quadrant. So we'll say positive radius 7 and 150 degrees would put me in the exact same spot as that rectangular coordinate point. Or if I go over here 330 degrees, but then I have a negative radius, then I can go there. So it would be like here versus here, or I could go backwards 30 degrees with a negative radius, or I could go forwards. No, let's go backwards. So I would go backwards 210, but with a positive radius. And there we go. Two more. Now this one is kind of easy because it's on the xy coordinate plane. If I ask you to graph the coordinate point negative 3, 0, 1, 2, 3, up 0. Then I ask you to tell me what the rectangular or the polar coordinate points are. Well, you could say, okay, I'm going to go, so it's negative 3 on the x and y, right? Because you're going to the left 3. But it's a positive 3 if you think in the positive direction, as far as the radians go. Or as far as the angle goes. You can just go the angle and then you go out 3 from the center. So it's all directed distance. So we could say that this coordinate point is 180 degrees, or pi. Well, I'll go ahead and do pi. Pi radians, so that's my theta, and then out a radius of 3. That's my radius. So that would be this direction. Now if I go backward, that's not a circle. If I go backwards, then I could say still a radius of 3, but go backwards pi. Same diff. The other option is I could say, well, go aim here, which is 0 degrees or 0 radians, I guess I could say, and then have a negative radius. Yeah? And then there's no, I mean, like, this is the same thing as 0, and I could say 2 pi. I can't say it's negative 0, but, there you go. It did say find two pairs of polar coordinates, so those would be good. Those two, these two, whatever you want to do. Okay, last one. So for this one, I've got negative 6 and negative 6 root 3. So that's the x and that's the y. I know that x squared plus y squared equals r squared. So that would mean negative 6 squared plus negative 6 root 3 squared equals r squared. Because I'm picking pretty points so that you can do tangent inverse without having to use a calculator, you always get these patterns. You notice how it's like one of them and three of them once you square them? Negative 6 squared is 36. Negative 6 squared is 36 times the square root of 3 squared, which is 3. 136 plus 3 36s is 4 36s. Now, the last time it helped because the 4 and the 4 in the denominator simplified out. Here it helps because when I take the square root, I can take the square root of 4 and take the square root of 36 instead of 4 times 36. Although 4 times 36 is just 144. Blah. 2 times 6 plus and minus 12. Okay? So I've got a radius of either positive or negative 12. And then theta equals tan inverse of y divided by x. Or tan inverse of the square root of 3. Or tangent of what angle equals the square root of 3. So I'm going to go to my unit circle. Square root of 3 is gotten by saying a y divided by x, where the square root of 3 is the y. So 1 divided by the square root of 3, square root of 2 divided by square root of 2, square root of 3 divided by 1. This one, right? So I need a positive square root of 3, and that would get me, this one would give me that, so that would be pi over 3. If in radians, I would say that. If I was in degrees, I would say this. And the only other one between 0 and 2 pi would be across, right here. Y divided by x, negative square root of 3 divided by negative 1 is positive square root of 3. So we're talking 4 pi over 3 or 240 degrees. So then the question is, what quadrant are we in? So this coordinate point is a negative x and negative y. Negative x, negative y. That puts me in the fourth quadrant. So I know that if I want to do the polar coordinate, if I want to go ahead and just go to the fourth quadrant, 240 degrees, then I would use the positive radius, because I'm already where I need to be. But if I want to say, let me go to the first quadrant and pop across the pole, so from here to here, then that would be a negative radius. Cool? So, just a reminder, we're looking at something here versus here. I always like to put a dot where I need to be and then an X where it's across it. So we've already gone this direction, 240 degrees, 12, and we've gone this direction, 60 degrees. Oh, crap, I got it backwards. Dadgummit. This is the coordinate point, this is across the pole. So 240 degrees with a positive radius, and then I've also gone 60 degrees with a negative radius. Going backwards are the other two options. I could go backwards 120 degrees with a positive radius, and then I could go backwards 300 degrees with a negative radius. And there we go. Okay, that is it for polar coordinates.